Hello guys, welcome to today's video. In today's video, we are going to do some questions on the inequalities of absolute value function. Okay, I hope you're getting my voice. Okay, so this is going to be the final video of this absolute value function series. Okay, so let's get started. Okay, so question number one given to us is absolute function x plus 3 is less than absolute function x minus 4. We have to sketch the graph, and we have to represent the region that this inequality denotes on the graph. Okay, now see here, I can write it here first. Okay, the first one is absolute function x plus 3 is less than x minus 4. So if you look at this inequality, we are given with two functions, right? This is our first function. I can say this is our f1 function number 1, and this is our second function f2, right? So if you compare these individual functions, with the equation of transformation, so which says the equation of transformation, right? So we are talking about absolute value function using transformation. The equation of transformation says that y equals plus minus a x minus h plus k, where h represents your x-intercept and k represents your y-intercept. I hope this thing is clear to you. Okay, now if I take function f1 equals x plus 3, okay, and if I compare f1 equals x plus 3, and on comparing this function with your equation of transformation, what will we get? We will get what? Our x-intercept, that is h is going to be minus 3y. Here I can break this positive into negative of negative 3, right? Makes sense? So h is going to be minus 3, means your x-intercept is going to be minus 3, and your k is going to be 0, means your y-intercept is going to be 0. Okay, so I hope this thing is clear to you, right? Then let's take the second function, that is x minus 4, right? And on comparing the same function with equation of transformation, we will get x-intercept is going to be 4, and y-intercept is going to be 0. Now this hk can be represented in the form of ordered pair of numbers minus 3, 0. What does it mean? It means for the graph of this absolute function, the vertex is going to be formed at minus 3, 0. And here, if I represent this thing in ordered pair of number, it's going to be x-intercept, y-intercept, means the vertex is going to be formed at 4, 0 for this. Okay, so now what we can do is we can we can draw the graph, right? We can sketch the graph. Okay, so this is here +1, this is +2, +3, +4, +5, +6. And on this side, -1, -2, -3, -4, -5, -6. This is 1, 2, 3, 4, 5, 6. This is -1, -2, -3, -4, -5, -6, -7. Okay, and so on. This is x-axis, this is y-axis. Okay, now there is one more thing to notice here, is that this is just a simple inequality. What does it mean? It means that here we do not have addition of two absolute functions on either side of inequality, right? Otherwise, what we could have done is we have to draw the number line, and then we have to see how the collective how the function collectively is going to behave in the particular domains. If you don't understand what I'm talking about, you can just refer to the previous video. Okay, we did it on addition of two absolute value functions, right? Now see here. Here for this one, f1, it's going to be at -3, 0. Okay, and for this one it's going to be at 4, 0, 4, 0. Okay, right? So we can check the when. Okay, for this one we can write y1 is x, or y equals x plus 3. Okay, because we want to find values of y. We want to see how y is going to behave when we put in different values of x. Okay, so here x plus 3 means this one, right? If I put -2 here, -2 plus 3, it's going to be 1. So -2 is 1, this one, right? And if I'm going to put -1, it's going to be 2, this one. If I'm going to put 0, 0, 3. And if I'm going to put 1, 4, 1, 4, this one. If I'm going to put 2, 2, 5. If I'm going to put 3, for 3, it's going to be 6. Okay, so this is going to be, this is going to represent what? Because see here, x plus 3, it's going to be x plus 3, x greater than equal to -3, and minus of x plus 3, x less than -3. Now, if you look at values of x, it's greater than -3. It means the equation of line here is going to be x plus 3. So y equals x plus 3, right? I hope you understand this. Now, we can do same for put values less than -3. Put -4, -4 plus 3, 1. So it's going to be this 1. -5, -5, it's going to be 2, 2. So this one, okay? So we are going to get the points, or we can say that on this side is going to be the reflection of this, right? So here, your graph is going to be this. Okay, this is going to be the graph, and it represents y equals minus x plus 3. Right? See here, why? Because for x less than 3, y is equal minus x plus 3. This is simple because when we define absolute value function, we always say it's x if x greater than equal to 0 minus x if x less than 0. So we are just making use of the basic things, right? So we are done with it. Let's check other one. So the other one given to us is y equals x minus 4, x minus 4. So it's going to be x minus 4 if x greater than equal to 4, minus of x minus 4 if x is less than 4. Okay, so x minus 4, this is 4, okay? For values greater than 5, 1, 5, 1, 6, 2, 6, 2, then 7, 3. So it's going to be like this. Okay, it's going to be like this. And what it is going to represent, this one, y equals x minus 4, right? Okay, good. Now check for the values left to minus 4. 3 minus 4 minus 1. So sorry, 3 minus 4 minus 1 absolute value function 1. So it's going to be this. For 2 minus 4 is going to be 2. And for 1, it's going to be 3. So it's going to be 3. It's going to be here. And for 0, it's going to be 4. Okay, so you will get something like this. Let me use other color. Okay, blue. So it's going to be 4. Okay, this is going to be something like this. Right? Now, this is going to be y of minus negative of x minus 4, right? Now, interesting point here is that these two lines are meeting at this point, right? At this point. So we must know the coordinates of this point, right? So let's say this point is here, P, okay? So see here, what we do, because we still haven't started this thing, the straight lines, okay? So you have, when two lines meet each other at certain point, it means at that point the value of y of both lines becomes same, right? Or you can equate both the lines, right? So here I can say finding point of intersection, right? Intersection. Okay, so P is the point of intersection. So I can say the coordinates of P is obtained by equating these two lines. X plus 3 equals minus x plus 4. Okay, if you solve it further, 2x is going to be 1 and x 1 by 2. 1 by 2. So if you put x y equals 1 by 2 plus 3, right? So it's going to be 1 plus 6 by 2 means 7 by 2. So y is going to be 7 by 2. 7 by 2 means 3.5. See here. So point P will be having coordinates 1 by 2 and 7 by 2. Okay, now what you need, now see here, this black curve represents absolute function x plus 3, and this red and blue lines, it covers absolute function x minus 4. Okay, now we have to find the region that satisfies this inequality, x plus 3 less than. So what does it mean? It means we have to look for that region where black curve lies below your red or your blue curve. Okay, or I will say this is going to be the blue one. Okay, blue one. So we have to find a region where black curve lies below your blue curve. Okay, so if you see, okay, what region would that be? Uh, this region, see here, this region, for these values of x, for these values of x, for these values of x, the for these values of x, the black curve lies below your blue curve, right? So this is your here, x is your, x is your, x is your 1 by 2. Okay, so I can erase this, or I can write here. I can just write here. I can just write here. And if you extend these lines towards this side, uh, I don't think that they are going to meet. Seems like they will go parallel. Okay, but for this region where I can say it's x less than uh, x, value of x is going to be 1 by 2 or minus 3 to 1 by 2, right? Minus from here to here, the black curve, it lies below this blue curve. So I will say, so the domain is going to be minus 3 to 1 by 2. Okay, so this is going to be your answer. Okay, we can even check for this. For more values, it will go here, right? And uh, they are meeting here, 4 4 uh, uh, these curves will meet. Let's see, minus x, I will try to find the point of intersection if they will meet. Minus x minus 3 is equal to minus x plus 4. Okay, so minus x now. So they are not going to meet, right? They are not going to meet. So we can say that, we can say that even for these values, right? Even for these values, even for these values, even for these values less than minus 3, because they are not going to intersect each other, because if you try to find the point of intersection, it doesn't exist, right? So it means they will stay parallel. Okay, so we can say here, minus 3 to minus infinity. Okay, because this is also going to, this region will be covered within that range. Okay, I hope that makes sense. Okay, but more precisely, if you want to say, then yes, this is going to be your uh, right answer. But if you just want to expand your horizon, and you just want to take one step out of the box, then you can check the point of intersection. So you can see point of intersection doesn't exist here. It means that for in this whole region, this line will stay below this because they are parallel. So that's why I said minus 3. Sorry, not minus 3. It's going to be minus infinity to 1 by 2. Minus infinity to 1 by 2 from here to negative infinity. Okay, I hope this makes sense. Let's move to the next. Let's move to the next one. So I'm just going to erase few things. Okay, so next question given to us is uh, it is I don't want to erase everything. Okay, this can be done later. Okay, the next question is we have to solve this inequality 2x absolute function 2x greater than absolute function x plus 3. Okay, this is the question. Okay, so here we can say this is our f1 and this is our f2, right? So f1 is absolute value function 2x. Okay, now here we don't have x-intercept means 0, y-intercept 0. Okay, it means our vertex is going to be formed at origin, right? F2 is x plus 3. If you compare this equation with equation of transformation, then your h is going to be minus 3, x-intercept minus 3, and y-intercept 0 means minus 3, 0. Okay, so vertex will be at minus 3, 0. Okay, so minus 3, 0 means you will get one vertex here and one is going to be here at the center. Okay, now this let's take y equals absolute function 2x. Okay, now uh, 0 x0 y0 x1 y2 x2 y4 x3 y6. Okay, so this is going to be like this. Y equals 2x. Why? Because 2x, x greater than equal to 0, minus 2x, x less than 0. You know this thing. This is the basic of absolute value function. Okay. Let's move to the other side. Same, minus 1, 2, minus 2, 4, minus 3, 6, minus 4. Okay, so if you join these points, okay, so this is y equals minus 2x, right? Now let's take the other function. What is that? X plus 3. X plus 3, we did it before too in the previous question. Okay, y equals x plus 3, absolute function x plus 3. So vertex will be formed here. Greater than, see here, x plus 3. If x is greater than minus 3, minus of x plus 3 if x less than minus 3. Okay, so if greater than minus 3 means minus 2, minus 2 means 1, minus 2y is going to be 1. Okay, minus 1, y is going to be 2, y is going to be 2. This is point of intersection. Okay, and then x0 y3 x0 y3 x4 x1 y4 x1 y4. Okay, x2 y5 x2 y is going to be 5. It's going to be 5. X6 y is going to be 9. Okay, so this is the line. Okay, this is the line, and this line represents y equals x plus 3. Then y equals negative x plus 3 means this line, right? So check for the values less than minus 3, minus 4, 1, minus 5, y 2, 2, minus 6, minus 6, 3. Okay, so it's going to be this. Okay, it's going to be this. Okay, now what you need, this is y equals minus x plus 3. Now see here, the question says you have to find absolute function 2x greater than x plus 3. So this is your 2x 2x greater than means you have to you have to find you have to find the domain of this blue graph for which the blue graph stays above the black graph. Okay, so where does it happen? So you can see uh, it is below black graph from here to this side and from here to this side, right? So we are only interested in this part. See here, which part? This part and this part. Okay, so what we need here, we must have point of intersection, right? We know this point of intersection. This point of intersection is minus 1 2. Okay, so I can say here this point P is minus 1 uh, and 2, right? We have to find this point of intersection. So equate both these lines. 2x equals x plus 3 means x equals 3. Okay, so 3 is, they will intersect at x. Okay, 3, so y is going to be 6. Y is going to be 6. So this point, actually they are supposed to meet here, right? So because I'm just sketching graph here on whiteboard, but when you take accurate measurement of accurate measurements, then you will get point of intersection at 3 6. This is going to be 3 6 Q, right? So this is your 3. It's going to be somewhere here, right here. This is going to meet here. Okay, so this 3 x equals 3. So see here, for x greater than 3, this graph, the blue graph is going to stay above black graph. And if you see this region, for x, this is x equals minus 1. So if you look at this graph for x less than minus 1, this blue graph is going to stay above black graph, right? Black curve, sorry. So what does it mean? It means we have to conclude it. So can I say x must belong to minus infinity to minus 1 union 3 to infinity. So this is going to be your answer. Okay, I hope you understand this concept, right? Greater than means it must stay above. Okay, so above these points, the blue curve is going to stay above the black curve. Okay, so that's the answer. Okay, if you have any doubt, you can see and you can ask. Okay, else we'll move to next one. All right, so I'm just going to erase few things here. Okay, so let's do it. Okay, question number 3 says 2x plus 5 absolute function greater than equal x minus 1. Okay, equation of transformation is this. Function 1 is 2x plus 5. So here x is going to be minus 5 by 2, which is minus 2.5, and then k is 0. K is 0, right? And function 2 is absolute value function x minus 1. Here x-intercept 1, k 0. Okay, if you arrange them in ordered pair of numbers, x-intercept, y-intercept, here it is x-intercept and it is y-intercept, right? So let's sketch it. Okay, first we'll deal with y equals 2x plus 5. See here, 2x plus 5, x greater than equal to minus 5 by 2, and it's going to be minus of 2x plus 5, x less than minus 5 by 2, right? Okay, so I hope you can see it clearly. Okay, here 2x plus 5, it means the vertex is going to be here, minus 2.5. Yes, so minus 2.5 here, this point. Okay, so let's see for greater than, right? So for 2 to 4, for 2 it's going to be, for minus 2, minus 4 plus 5, 1, 1, minus 1, minus 1, 3, minus 1, 3, 3, then 0, for 0 it's going to be 5. Okay, so your curve is going to be like this, your line is going to be like this. Okay, 5. Okay, and on the other side, less than minus 5 by 2, if you take minus 3, minus 3, minus 6 plus 5, 1, 3, 1, minus 4, sorry, minus, yes, minus 4, minus 8, 3, 3. So you will get like this. Okay, this is going to be 2x plus 5. This is going to be y equals minus of 2x plus 5. Okay, and then let's do it for the other one. X minus 1, right? It's going to be x minus 1 if x is greater than 1, and minus of x minus 1 if x is less than 1, right? So the curve is going to be formed here, right? So let's check for values greater than 1, 2. For 2, it's going to be 1. For 3, 2, 3, 2. For 4, 4, 3, 4, 3. Okay, so if you connect this, okay, if you do it for values less than 1, 0, 1, minus 1, 2, minus 2, 3, 2, 3. So it's going to be like this. It's going to be like this. Okay, it's going to be like this. We'll see. This one is going to be y equals x minus 1. This is going to be y equals minus of x minus 1. Okay, now we have to find point of intersection. So now see here, they are going to intersect because it is clearly evident, right? But this one, I think they are going to intersect if you will extend both these lines, right? So let's find the point of intersection first. Points of intersection. Points of intersection. Okay, this is, let's say this is P, and this one is going to be Q. So coordinates of P would be this line, minus x plus 1 is equal to 2x plus 5, minus 3x equals this is minus x plus 1, right? 2x plus 5, so it's going to be minus 3x, 4x minus 4 by 3, minus 4 by 3. So x is, this is x equals minus 4 by 3. Let's check. So okay, 4 by 3, so it's going to be what's going to be the value of y? Y equals minus of x minus 1, right? X minus 1. So x is minus 4 by 3 minus 1, 7 by 3, right? 7 by 3 minus 4 by 3 and 7 by 3. So if on further extending, if they will intersect, let's say that point is Q and I want to see what's going to be the coordinates. So let's equate these two lines. Minus 2x minus 5 is equal to minus x plus 1. It's going to be x minus x is going to be 6. X is going to be minus 6. So see here, these lines are going to intersect here, here, here at this point, minus 6, minus 6, x equals minus 6. This is x equal minus 6. Okay, so now come to the question, 2x plus 5 greater than x minus 1. Oh, sorry, you have to, what you have to find? You have to find the region where blue curve stay above the white, sorry, stay above the black curve. So this point, they are going to intersect, sorry, the blue one will go up, right? The blue one will go up and the black one will stay below the 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 blue one, right? So see here, what's going to be my domain? What's going to be my domain? So x is going to be here for all the values of x less than minus 6. So I can say minus infinity to minus 6. But here, greater than equal to means the point on the curve are also included. So this is going to be closed, right? And union here minus minus 4 by 3, again point on the curve, that's why closed, to plus infinity, okay? So this is going to be your domain, right? So if you see, for all these values, x greater than minus 4 by 3 or minus 4 by 3, blue will stay above, and for all the values of x equal to minus 6 or greater than or less than minus 6, this curve blue is going to stay above. Okay, so that's how you have to do it. Okay, so thank you very much for watching this video. So today we have finished your absolute value functions. Okay, if you have any question or if you find any question that seems difficult to you, and if you need any kind of help, just let me know in comment section. Okay, so thank you very much. Next time I will see you in the next video. Okay, and we are going to start straight lines. Okay, so until then, take care of yourself. Bye bye.